presenting biorush, modernizing a field still reliant on backlogged manual lab work and enabling equitable, timely justice across jurisdictions. biorush automates forensic biology with a lab-on-a-chip platform, delivering results in under 4 hours. To present, we have Mohammed. Mohammed, over to you.
Thank you, Mubin. Hi, I'm Dr. Mohammed El Sayed. I'm the founder of biorush, automating forensic biology, because every case deserves to be a rush case. I recently met Julie Weil, a survivor of sexual assault. Now she runs a survivor advocacy organization called Not Just Me Foundation. After reporting the assault, it took 6 months before an arrest was made. And during that time, she and her family lived in constant fear, afraid to leave her home. She told me she couldn't sleep during those 6 months, always afraid he'll come back for her family. The reason it took so long to make an arrest was that police had no leads other than DNA evidence, which can take months to analyze. Several nonprofit organizations, including Not Just Me Foundation, pressured governments to impose deadlines, and now forensic labs are frantically searching for ways to meet these deadlines. biorush will enable forensic labs to meet these deadlines by providing results in under 4 hours. According to UNICEF, more than 370 million girls and women under 18 were sexually assaulted. That's 1 in 8. And according to Statistics Canada, sexual assault is the crime that is least reported to police. The long time it takes to investigate those crimes mean that victims don't have confidence in the justice system. Perpetrators know they're not going to get caught. DNA evidence is no longer a deterrent to crime. Evidence is collected at a medical facility, transferred to police, and then to a forensic lab. Forensic labs are overwhelmed. In the US and Canada, there are 200 forensic labs servicing 20,000 law enforcement agencies. Most labs are always understaffed, with demand exceeding their capacity, so there's always a backlog. A typical forensic lab would process thousands of DNA evidence per year, over half of which are related to sexual assault. It used to be normal for labs to take years or not even process evidence. After new legislature and deadlines, labs have invested billions of dollars in infrastructure upgrades and new hires to increase their capacity, but they still struggle to meet these deadlines, especially with sexual assault evidence. Now, turnaround times in the developed world are commonly 4 to 6 months, sometimes more. So let's step inside the lab to see why it takes so long. And that's exactly what I did. I stepped into the Ontario Centre of Forensic Sciences, which was one of the largest forensic labs in North America and part of the Ontario government. And what I found was a team of brilliant forensic scientists working together on this very labor-intensive workflow. And I also talked with dozens of forensic labs from all over the world to make sure this is representative of the market. First, there's always a queue. So we're lucky in Ontario. Our queue is only about a month or two. Most labs I talk to have a much longer queue than that. Once the lab actually starts working on the evidence, there's 3 steps. First, serology. Evidence is examined under a microscope. Second is differential extraction. This is a method to separate sperm DNA from non-sperm DNA. And third is DNA analysis itself that results in the profile that can be used to identify the perpetrator. In extremely urgent situations, evidence may be designated as a rush sample, jump the queue, and would go through this whole process in a day or 2. But for routine casework, when the lab needs to process hundreds of samples a week, the samples are batched. Each of these steps is carried out by a different team on different days, and the logistics required to process these samples mean that the average turnaround time is in months. Our mission is to enable all samples to be treated as rush samples. The infrastructure upgrades I mentioned earlier automated to a large degree the DNA analysis portion of the workflow, and the customers I spoke to told me that differential extraction is the most labor-intensive part, and the second is the serology. So these are the biggest bottlenecks and represent the biggest pain points. With that in mind, in collaboration with these brilliant forensic scientists at Ontario Centre for Forensic Sciences, we came in with a laser-focused solution that addresses these specific pain points. Our solution brings down the hands-on time for these 2 steps to only 15 minutes. 1-5. And here I'll go into a bit more details on how this actually works. biorush is composed of 2 modules. For automated microscopy, we learned from our conversations with forensic scientists that the biggest pain point is staining. So we developed a generative AI model that can do virtual staining. Top row are images of cells extracted from a swab, stained with two fluorescent dyes. The bottom row was our trained AI model taking in just the bright field image and generating images as if they were stained. Now, automated differential extraction, is enabled by digital microfluidics. Digital microfluidics is a programmable microfluidic technique with no channels. And so this makes it possible for the same chip to be used for different sample types and even different applications altogether, where each sample type can have a different protocol. Here we have the sample in pink, and these are the reagents used in the differential extraction process. And all this is happening automatically. Our program activates electrodes serially to perform these tasks. Sample is mixed with the first reagent and the second, third, and each of these steps has a different optimum temperature, different duration, which can all be easily programmed and automated. With this workflow, labs can process all samples as rush samples as soon as they arrive. No need to batch samples, no backlogs, so no month-long waits, quick results, quick action, safer communities. But that's not all. We also showed compatibility with the Andy 6C rapid DNA instrument. And let me explain why this is a big deal. Many police stations are now using rapid DNA instruments to process samples themselves without having to send the sample to a lab. But these types of samples are samples that contain DNA from only one person. So the biorush modules do all the pre-processing work. And now this workflow enables analysis much earlier at the police station or even immediately after sample collection at the hospital, operated by a nurse. This slide shows our competitive analysis across both modules. On the microscopy side, biorush uniquely eliminates staining and fully automates image analysis. And on the differential extraction side, biorush is the only platform that automates the process while maintaining performance at par with manual methods. And when paired with rapid DNA, this enables same-day results, allowing every case to be treated as a rush case. Worldwide, there are an estimated 30 million cases a year, but only cases reported to police get analyzed. So we took that into consideration when assessing the market, and targeting Canada and the US, there are 150,000 cases reported to police per year. I'm an electrical engineer. When I was at AMD, I realized we're building faster chips, enabling AI, revolutionizing industries, not biology. And that's why I decided to do my PhD in biomedical engineering in Professor Aaron Wheeler's lab. And we're in this together. He's a serial entrepreneur and a well-known figure in the field of microfluidics and lab and chip automation. And moving forward, we have a packed year ahead, focusing on talking with customers and building the solution. We have 3 pilot studies planned, and we have letters of support from 2 of the largest forensic labs in North America, Ontario Centre of Forensic Sciences and Bodhi Technologies. Delayed justice can lead to fatal results. When I heard Julie Wild's story, lots of other stories where delays led to fatal results or grave injustices on the other hand, I realized that we're building something that is urgently needed. We're building technology that will empower victims to report assaults and will enable much faster investigation. Victims will feel like they matter, their story matters. Thank you.
Thank you very much, Mohammed. This is biorush. The first question in chat. Any potential alternative applications? Are AI results accepted as evidence in court?
So for the first question, of course, I'm just focusing on, because we have these pilot studies, and so for the next year, that's our focus. But we do have in mind, in following years, other verticals. Acceptance in court, it's the way it's going to be used is it's going to help the expert analyst to nail down, to reduce their time. Right now, they can spend hours searching manually or hours doing staining. This way, it will just help them zoom in to where exactly the sperm are and verify, and then it will be the expert analyst who actually goes to court and talks about the results.
Great. And then one more question. What remains to finalize and further commercialize biorush and use it for casework?
So when I spoke with our customers, one thing they really want is reagents to be packaged within the device. Currently, the current iteration, which is good for demos, is we have to load the reagents on the device and then load the samples. So the next iteration, what we want to do for our pilot ready version is to pre-package the reagents on chip.
Great, Mohammed. That is time. His contact information, biorush contact information, is on the slide. Feel free to reach out to him for further contact and information. Thank you very much.